Hello.
Hello.
Hello. Hello, students. Are you there?
Yes, sir.
Okay. Today we start circular motion, and the lecture will be very basic. We started the basic lecture. It is basically a level 1 lecture. Level 1, which is good for cbse exam. Or board exam, right? And then we will go to the level 2, level 3, and so on. Level 1 includes, we will start with basic definitions, and basic equations, basic derivations for circular motion. Let us start with, in order to understand circular motion, first of all, we have to understand angular displacement. Angular displacement, we need to understand what is it. See, if this is a particle, let me suppose, and particle moves like this. It moves like this and reaches here. It started its motion at time t1, and it ends its motion at time t2. What I need to define its angular displacement about a point. You must know angular displacement is always defined about a point. That point is fixed. Let this O point be the fixed point about which I have to define the angular displacement. So what you do is that when a particle moves from here to here, first of all, this particle has radius vector r1 about this O. And then when finally it reaches here, it has a new radius vector r2. Right? Particle moves from here to here. It is radius vector, that is r1. It turns from this position to this position. And this angle, delta theta, is called angular displacement. That means when a particle goes from here to here, it is radius vector about this point O turns delta theta. In fact, when a particle moves over this path, the distance covered is delta s. And if you join these 2 points, this is delta r, this is displacement, right? And the time interval delta t is t2 minus t1. In fact, you can define a whole lot of physical quantities here, but we are concerned only with delta theta. So what is delta theta when a particle moves from here to here? What is delta theta? Don't write on the board. Don't write on the board. So I will define the angular displacement like this. You can write it down also, or you can put it like that and later have a screenshot. Angular displacement, the angle cut about a point by the radius vector. By the radius vector by the radius vector of a particle, is called angular displacement. Angular displacement. Angular displacement about a fixed point. Right? Okay. This is the angular displacement. Now the point is, what is this SI unit? The SI unit for angular displacement is radians. Okay. Now, if you want me to do something else, I can define, suppose velocity, I can define from the same figure. That is this delta, or that is displacement by delta t. I can also define speed, that is distance, actual distance, this path, by same delta t. But I don't need these two terms right now. Anyway, these things can be defined from the same figure. Okay. Now, the next thing that I need to do for circular motion is angular velocity. Angular velocity we will define. Now look at this. Look very carefully. Again, I will make the same figure so that I can remind you again and again of the basic thing. A particle is here. It moves up to here. Here is a fixed point. It is radius vector r1, and it is radius vector r2. It is delta theta, right? And this is actual path. And if you want to do this, it is displacement. Leave it out. The particle starts from time t1 and it reaches over here at time t2. And time interval is t2 minus t1. Now look at this. Angular velocity is the particle was moving from here to here. It is radius vector has cut an angle of delta theta, or it has described an angle of delta theta. In how much time it has described this angle? T2 minus T1 or delta T. The angular velocity is defined is the angle cut in 1 second, or the rate at which the angle is cut. That is the angular velocity omega, let us call it, is defined as the ratio of angle described to the time interval. It is SI unit is simply that angle by time, that is radians per second. Mathematically, omega is delta theta by delta t. Let's call it equation number 1. But now you must know that this omega, angular velocity, is a vector. Angular velocity is a vector. And is defined about a point. There is no meaning of saying what is angular velocity unless somebody asks you what is angular velocity about a particular point. Because angular velocity and angular displacement, these are always defined about a fixed point, right? Okay, that's right. Okay, this is all about angular velocity, just angle divided by time. Now let me go to one more point, that is what is instantaneous angular velocity? Angular velocity at a particular time, not from one time to another time. So that is a very simple thing. If I want to find instantaneous angular velocity omega, that is delta theta by delta t again. But we have to take a limit as delta t tends to 0. Yani this delta t must be very small. And this is represented by just a differentiation of theta. So omega is d theta by dt if it is instantaneous. It is instantaneous value. It is instantaneous value. Okay. Now, that's it. Omega is also a vector. It is also a vector. Asif Ali, आप म्यूट कीजिए आप अपना ये
सर
आसिफ अली को कहो म्यूट करें because it creates noise.
सर इंटरनेट इज वीक
है इस वक्त. आसिफ अली को कहो कि ये जो okay. Now, from here we will go to one more point, that is angular acceleration. We have gone angular velocity, and why not to go angular acceleration? Learn it also. Angular acceleration. If we suppose that omega, the angular velocity, is changing, if omega is changing, then we define angular acceleration. If angular velocity changes from omega 1 to omega 2 in time delta t, then angular acceleration is defined as the ratio of change in angular velocity to the time interval. So simple. Mathematically, angular acceleration alpha is omega 2 minus omega 1, that is change in angular velocity, divided by time interval t2 minus t1, or delta omega by delta t. Change in angular velocity by time interval. And the units are radian per second square. Unit, SI unit. SI unit is radians per second square. Instantaneous value, you can just have a differentiation of omega. That's all. Instantaneous angular acceleration. Instantaneous always by a differentiation. You must know that. Instantaneous alpha is d omega by dt. That is, if you know omega, you differentiate it, get alpha at any time. So if I tell you like this, suppose omega is equal to 2t square, and I ask you what is alpha, instantaneous alpha at any time, you do d omega by dt is just equal to 4t. So this is alpha is equal to just 4t. What is alpha at time t is equal to 1 second? 4. Time 2 is equal to 2 seconds? 8. 3 seconds? 12. So you can do that by just by differentiation. That's easy. Now, these are the essential things to understand this circular motion. Now, I want to do one more thing for you. Fourth point, possibly, yes. Relation between speed and angular velocity and acceleration and angular acceleration. I have a relation between speed and angular velocity. I have a relation between acceleration and angular acceleration. I want to derive these relationships for you so that it becomes easy for you later on to do circular motion. And these are very essential things, and questions are asked about these relationships. So again, I will tell you, I want to find relation between velocity and omega. And I want to find relation between acceleration and alpha. We have to understand this in full. Now see, this is velocity, this is angular velocity, this is acceleration, this is angular acceleration. I want to find a relationship between all these. Now see, how can I do it? See, it's a particle. Let me suppose it moves in a circle. Particle moves in a circle. And this is a, oh, sorry. Let me make a good circle here. This is a particle moving in a circle. Particle is here at time t1, let me suppose, and reaches here at time t2, and this is center O. This is radius vector r1. This is radius vector r2. You may say that this is the same, r1 and r2. No, as a vector it changes. Magnitude is the same. Therefore, it's r1. You can, at most, you can write r1 vector is equal to r2 vector is equal to r. But you can't write r1 is equal to r2 because they have different directions. Now, from here to here, the distance covered is delta L. And let me suppose this is theta or delta theta. Can anybody tell me what is the relationship between delta L and delta theta?
Delta
Arc
theta
length.
equal to delta L by R.
Delta L, that's arc, is equal to this R, magnitude of this R1 and R2, that is R, or delta theta. That's what you know. Arc is equal to R theta. If I divide both sides by delta T and delta T, this delta L by delta T, this is distance covered by time, that is speed. Isn't that?
Yes, sir.
That is speed. Delta L, path covered by time is speed, is equal to, this is R, and delta theta by delta T is omega. You got a nice relationship. And generally you say V is equal to R omega. That is this. Okay. If I differentiate this V, that's dV by dt, isn't that? And R is same constant. It is d omega by dt. This dV by dt is what?
Acceleration.
Acceleration? No, it is not acceleration. It is tangential acceleration because it is rate of change of speed. You must always know rate of change of velocity is acceleration, and rate of change of tangential velocity or the speed is tangential acceleration. That is R omega or alpha. You got both the relationships in a very short way by using the simple logical this circuit, logical this figure number 2, let you suppose. इसको note कीजिए आप, because this is very important relationships. V is equal to R omega and tangential acceleration is equal to R alpha. But you must mark it well in your minds that it is tangential acceleration. What is it? Tangential acceleration it is. Okay? These are the relationships that you need to remember for circular motion. Okay. Let me
Hello,
go. Hello.
sir. What is this R?
R is the radius of the circle.
Is it R1 or R2?
R1 is equal to R2 is equal to R. Magnitude is the same.
Okay, sir. Okay, sir.
That's right. Good. Very good question. Okay. अच्छा अब
Sir, is
देखो,
vector?
आप जरा देखिए, इंटरेस्टिंग चीज देखिए आप. Now we are doing circular motion. So I must tell you one thing. Force related, how it is related to velocity. What force does to velocity? This is a very important thing. We all know that when we apply force on an object, its
Acceleration of changes.
velocity changes. Don't we know that?
Yes, sir.
Yes. I will write it down. If force is applied to an object, its velocity changes. That is well-known fact. Or momentum changes, that is also there. Mass remains constant, it is velocity that changes and finally changes the moment. Okay. But here, there are certain important things. Like velocity changes means if magnitude of velocity change, magnitude changes, or direction changes, or both. वेलोसिटी चेंज होने का मतलब ये है कि डायरेक्शन भी चेंज हो सकता है, मैग्नीट्यूड भी चेंज हो सकता है, या दोनों चेंज हो सकते हैं, राइट? अच्छा, नाउ सी, suppose it's a particle moving with velocity v and force is applied in this direction and it makes angle theta and theta is less than 90, acute angle. In that case, what happens? Now see what happens. I will tell you. You can make two components of this force. One component is in this direction, that is f cos theta, and one component is here.
F sin theta.
आप यहाँ भी कर सकते हैं वो और यहाँ भी कर सकते हैं, लेकिन यहाँ करने का मतलब ये है कि it will create a misconception.
It will not.
Why not use f sin
Theta.
theta, right? This f cos theta is in the direction of velocity,
Velocity. We will add it.
right? This f sin theta is perpendicular to velocity, isn't that? It is normal to velocity. So here I will write this f cos theta
Plus.
increases the speed. Increases the speed because it is in the direction of velocity. Increases the speed, right? And this f sin theta changes direction. So here you remember that one component changes the speed and another component changes the direction. The component which changes the direction is normal to the velocity. The component which increases the speed is parallel to the velocity. That is what you have to remember. Now see one more point. Here angle is acute, that you must know. I will make now angle obtuse, more than 90. Let me see what happens. It is particle velocity v. Now the force is like this, and it is theta, right?
Opposite speed will decrease.
Yes, that make the fourth component again. This is f cos theta.
Yes, sir. It will
Basically, it
decrease.
is 180 minus theta, and it is f cos of this 80 minus theta. That's again f cos theta, right?
F cos theta. Yes.
And this is f sin. Try to listen to me very carefully, and I will again explain you. It will be also what you call as it will be recorded, and then you can watch it again. This force is resolved into two components, back and up. But you say this is theta. How this is f cos theta? You can make this 180 minus theta, then it is f cos of 180 minus theta. That is again f cos theta. So you need not worry about that. But here, f cos theta is opposite to velocity. So this f cos theta will reduce the speed. Number second, this f sine theta will again change the direction. Right? So the force which is normal to the velocity does not change the speed. That only change the direction. That only change the direction. That only change the direction, right? Okay. Now see, try to understand me here. I will also show you the third case. These things you have to remember by heart so that you can understand other things easily. Then there's no problem. Now there's a velocity v, particle moves, and force is in this direction, 90. There's no force parallel or anti-parallel to the velocity. So in this case, only the direction of velocity changes. Speed remains constant. Speed remains constant. Is that right? Okay. Okay. Now let me go to the sixth point. If a particle moves in a curvilinear path like this, here is a particle, now here, then here, then here. It's a particle here. It moves on this path. What's the direction of its velocity? The direction of its velocity is tangential to the path. Here the velocity is tangential. Here the velocity is tangential. Here the velocity is tangential. And if there's a force in the direction of the velocity, yes, in this direction, if there's a force, that means in this direction there's an acceleration. That's called tangential acceleration. What is this called as? What is this called as? This is called tangential acceleration. Please listen to me. This.
Sir, repeat.
मैं बताता हूँ. Let you listen. Suppose the particles moving in a curvilinear path. The velocity of the particle is always tangential to the path. अगर ये ऐसे इस path में चल रहा है तो अगर ये particle यहाँ है तो velocity इस direction में है. अगर यहाँ पर है तो velocity इस direction में है. तो अगर ये speed increase करना है, then there must be a force tangential to the path. Or then there must be an acceleration tangential to the path. जो अभी मैंने कहा कि if the force is in the direction of velocity only, then the speed will increase. So it is tangential acceleration in the tangential direction. So this acceleration in the tangential direction can be written as the rate of change of speed, not the rate of change of velocity. Please mark it well. पहले भी बताया ये. अगर speed change हो रहा है, let me write down the statement so that you remember it. If there is tangential acceleration, that increases the speed. And the relation is given by, and the relation is tangential acceleration is equal to rate of change of speed, not rate of change of velocity. There's another equation. V is equal to dv by dt. This is different and this is different. This is full acceleration, total acceleration rate of change of velocity. But tangential acceleration is rate of change of speed. This you mark well in your mind so that you can do things in an easy way. Okay, let me go to now important point, that is seventh point. Uniform circular motion. Uniform circular motion. Let me tell you what is uniform circular motion. Let me speak for a while, then I will make it right. Circular motion are very common in nature. Like Earth revolves around the sun, like electron revolves around the nucleus, like you can tie a stone to the string and you whirl the stone around your head. Moon revolves around the earth. You also sometimes try to move in a circle, but you must know when you try to move in a circle, you tend to fall. And you are on a bicycle and you move in a circle, and suddenly, while moving faster on a curvilinear path, you tend to fall. You have seen also in the aircrafts in the space trying to move in a circle paths. You have so many examples of circular motions, but circular motions are dangerous also. Now see, suppose there's a car moving on a road and there is a blind curve, and there are generally accidents on those blind curves. And you may have even seen that on the blind curves or on the curved roads, there's banking. I mean, the road is raised on one side. So these are the things that are very important in circular motion. So uniform circular motion are very common in nature. So first of all, let me tell you what uniform circular motion is. First of all, uniform circular motion is not a uniform motion. I mean, the velocity is not constant. When a body moves in a circle, definitely its velocity changes. So first of all, I must write it. Uniform circular motion is an accelerated motion. Uniform circular motion is an accelerated motion. This is the first thing that you need to remember. Accelerated motion. Okay. If it is accelerated motion, means there is acceleration in circular motion, there must be acceleration, isn't that? Isn't that? Should there be acceleration? Yes. The acceleration in circular motion in uniform circular motion is towards the center of the circle. I will prove it later on. Is towards the center of the circle. Okay. If it is a accelerated motion, that means its velocity changes. What about the momentum? Momentum changes because velocity changes. Momentum in uniform circular motion changes. Motion changes. Okay. Changes. Fourth, if momentum changes, please tell me, should there be force? Yes, because it is the only force which changes the momentum. Force is needed for circular motion. Force is needed for uniform circular motion. Number 5. Now you may ask me a question. Why it is called uniform, uniform, uniform? What is uniform in it so that it is called uniform? Obviously, there's nothing which is uniform in the uniform circular motion. So why it should be called as uniform? Velocity changes, momentum changes, there is acceleration in the uniform circular motion. There is force also which is toward the center. So why it should be called as a uniform circular motion in the first place? The answer is the speed remains constant. The speed in uniform circular motion remains constant. That is the only thing that remains constant. Okay. Now, if speed remains constant, can you tell me what should happen to the kinetic energy? Yes, everybody of you should say that, well, kinetic energy should remain constant. When speed remains constant, that is V remains constant and M is also constant. So why not 1 by 2 mv square? So in uniform circular motion, the kinetic energy remains constant. The kinetic energy remains constant. Try to understand and remember it. Okay, here again, something else comes out. If kinetic energy remains constant, then there is no work done. If you have done work energy theorem, that means work is just equal to change in kinetic energy. If the kinetic energy remains constant, there is no work done. Work is equal to K2 minus K1, final kinetic energy minus initial kinetic energy. But now, if kinetic energy remains constant throughout, the change in kinetic energy is 0, so work done is 0. So work done in uniform, work done by the force. Don't write on the board, don't write on the board. Don't write on the board. Work done in uniform circular motion, uniform circular motion is 0. That is one more point. Okay, now I have talked about the force. I have talked about, remove these arrows, please. Remove these arrows. Eighth, we have already said there's a force. The force in uniform circular motion, the force needed in uniform circular motion is mv square by r, where m is mass, v is the speed, r is the radius of that circle, और m r omega square. जब v को r omega का वैल्यू देंगे तो ये हो जाएगा, because we already know v is r omega. तो जब ये सबस्टिट्यूशन करेंगे तो ये हो जाता है. The force needed in uniform circular motion is mv square by r or mr omega square toward and is directed towards the center of the circle and is directed towards the center of the circle. That is all. These are some properties of circular motion. Now see, you may ask me why this, how do we know this is the force? This we will prove. Okay, this we are going to prove. Now let me go to this 8th point. 8th point is the centripetal acceleration. Centripetal acceleration.
9th point.
Is it 9th point? Okay, 9th point. Centripetal acceleration. That is v square by r or r omega square. Because by substituting v is equal to r omega, that will become r omega square. So v square by r or omega ka whole square by r, that is r square omega square by r. One gets cancelled, that's r omega square. ठीक? Okay. This what I have to do. इसका डेरिवेशन करना है बाज़ाब्ता. इसको कैसे हम कर सकते हैं वो मैं आपको करके देता हूँ. चलिए ठीक है. Okay. But please remove. Can you remove these arrows here from the board, from my board? Anybody there who has put these arrows on my board, can he remove these arrows? Please.
Erase करो उनको भाई.
In arrows को arrows erase करो, please. If somebody is playing mischief, it is not good. The arrows are still there. Okay, let me do it. चलिए, okay. Now see, it's a circle, right? I am made now circle in a nice way. It's a circle, and particle moves. Particle velocity here is v1. Here the particle velocity, let me suppose it is v2, and this is r1 vector. This is r2 vector, and this is angle delta theta. I want to find the acceleration of the particle which moves in a circle. If I could find the acceleration, then I will multiply that by m. That will give me the force. This is the center of the circle. This is v1 vector. This is v2 vector. But we know speed remains constant. Don't we know that? Yes, we can write r1 vector magnitude is equal to r2 vector magnitude is equal to r, because length is the same. It's the direction of the radius vector which changes when the particle moves over here. And what about the velocity? v1 vector magnitude is equal to v2 vector magnitude is equal to v, because speed remains constant. The magnitude of velocity remains constant. It is only the direction which changes. Okay. Now, I will draw this velocity I will draw here, keeping the direction the same. This v and this v1 is the same. And this is the v2, and this v2 is something like this, isn't that? I have to keep the direction the same, parallel. I have to keep the length the same. Here I have to keep the length of v1 the same. I have to keep the direction of v1 the same, parallel. So what is the angle between these two? Delta theta. Because here r is perpendicular, here r is perpendicular. The angle between two r's is the same angle between two velocities. Because here r is perpendicular, here r is again perpendicular. So whatever is angle between the radius vectors, the same is the angle between the velocities. Okay. Now, this is v1. This is v1. And this is, see here, this is final velocity minus initial velocity. When you connect the two tips of the vectors, it is change in velocity. v2 vector minus v1 vector, that is delta v. Okay. Length, this length is magnitude. This length is magnitude. Achha. Now, if you look at this, I mean, if you connect this, if you look at this triangle and this triangle, they must be similar, because the angle between them is the same. Two sides here are equal. Here two sides are also equal. Therefore, these two triangles must be similar. And we know the property of similar triangles. Let me say this is figure 1. This is figure 2. What we know, if the two triangles are similar, they have a property. What is the property of two similar triangles? The property of two similar triangles is this side by this side is equal to this side by this side. This is delta r. This side by one of the sides is equal to this side divided by one of the sides. So it is something like this. Comparing the two triangles, comparing.
Sir, repeat.
ये ट्रायंगल है ना बेटे, जरा देख, ये ट्रायंगल देख रहे हैं आप?
Yes, sir.
जब मैं ये पॉजिटिव साइन घुमा रहा हूं तो मैं इंडिकेट कर रहा हूं, ये देख, ये ट्रायंगल देखा आपने?
Yes, sir.
ये डेल्टा आर है ना, r2 माइनस r1, ये लेंथ. ठीक. अच्छा, और ये ट्रायंगल देख रहे हैं आप?
Yes, sir. Yes, sir.
इस ट्रायंगल में दो साइड्स इक्वल है कि नहीं?
Yes, sir.
इस ट्रायंगल में दो साइड्स इक्वल है कि नहीं?
Yes, sir.
और इनके दरमियान एंगल डेल्टा थीटा है. इसके दरमियान क्या है?
Delta theta.
तो ये दोनों ट्रायंगल्स क्या है? सिमिलर.
Yes.
तो जब हम इन दो ट्रायंगल्स को कंपेयर करेंगे, कंपेयरिंग द टू सिमिलर ट्रायंगल्स,
Yes, sir.
तो क्या लिखेंगे हम? ये साइड डेल्टा v बाय
divided by delta R.
Now delta V by its own this V.
So,
V1 कर दो या V2 कर दो, लेकिन उनका लेंथ तो सेम है ना.
Yes, sir.
ये जब आप इक्वेशन लिखते हो, इट्स ए लेंथ वाइज इक्वेशन, इट इज नॉट वेक्टर वाइज, बिकॉज वेक्टर्स डोंट डिवाइड, वेक्टर्स डोंट मल्टीप्लाई, इट इज मैग्नीट्यूड बाय मैग्नीट्यूड. तो यहाँ क्या लिखोगे आप? शाबाश, डेल्टा आर बाय, शाबाश शाबाश, डेल्टा आर बाय व्हाट?
R.
आर. R1 करो या R2 करो, लेकिन दोनों R1 इज इक्वल टू R2 इज इक्वल टू R, द मैग्नीट्यूड इज द सेम. इक्वेशन नंबर 1 कर दो. मैं इस इक्वेशन से निकालता हूं व्हाट इज द एक्सेलरेशन, और शायद दूसरे तरीके से मैं आपको बताता हूं हाउ कैन वी फाइंड द एक्सेलरेशंस टुवर्ड द सेंटर. फर्स्ट ऑफ ऑल आई विल फाइंड द एक्सेलरेशन. हैव अ लुक, अच्छी तरह से देख लो ये कैसे मैं मैथमेटिक्स में कैसे करता हूं. थोड़ा सा देख लो आप. ये देखिए, now delta V, change in velocity when a particle moves in a circle, is delta R into V by R. इस V को यहां कर दिया, ठीक, समझ आया? इस V को उठाकर यहां बिठा दिया,
Yes.
dividing both sides by delta T. Right? Okay. When we do that, so that comes delta V by delta T is equal to delta R vector V by delta T डिवाइड का जो किया है, और R अपनी जगह रहेगा. तो proceeding to limit, as delta T tends to 0, डेल्टा T को बहुत कम करेंगे, तो मैं ऐसे लिखता हूं, लिमिट डेल्टा T tends to 0, delta V by delta T is equal to limit delta T tends to 0, delta R by delta T into V by R. समझ आ रहा है ये?
Yes, sir.
ये देखो मैंने ऐसे लिखा, पूरा ये लिखा, सिर्फ प्रोसीड किया लिमिट, प्रोसीड किया लिमिट. अगर आपको थोड़ा सा भी एक्सेलरेशन का पता है, तो ये क्या हुआ? ये एक्सेलरेशन हुआ ना, चेंज इन वेलोसिटी बाय टाइम.
Yes, sir.
तो नहीं हुआ एक्सेलरेशन. तो डेल्टा आर बाय डेल्टा टी एस डेल्टा, ये तो वी है,
yes, sir.
ये तो और एक वी है, ये बाय आर है, तो ये होगा वी स्क्वायर बाय आर. अगर वी को वैल्यू दिया जाए आर ओमेगा by r, that is r omega square. So acceleration is equal to v square by r is equal to r omega square. So that's the acceleration. Now, what's force on the object which moves in a circle? This is called centripetal acceleration. This is called centripetal acceleration. Okay, now A is equal to V square by R is equal to R omega square. Now, what is the force? The force on the object, force on the object moving in circle, moving in a circular, uniform circular motion, circular motion is given by what? F is equal to ma, isn't that?
omega square.
Mass to multiply karoge na,
Mr omega square.
that's mv square by r is equal to mr omega square. That is great. Finished. But now, how can I prove that this force is towards the center? I have to prove that. How can I prove that this force is towards the center? Mathematically, or for that matter, graphically, or through the figure itself. Can I do that? Can I do that? Okay. I will try to do it for you. Okay. Let me see if you understand. This is circle. This is a particle velocity v1. This is a particle velocity, okay, v2, sorry. Okay, v2. This is r1. This is r1 vector. This is r2 vector. This is center. Now, this is the radius. This is the displacement. Now, let me draw a perpendicular. Let me go like this. यहां पर मैं बनाऊंगा जो मैंने अलग से बनाया, जो मैंने अलग से ट्रायंगल बनाया था, मैं इस लाइन पर वो बनाना चाहता हूं. जरा इस लाइन का क्या कर दूं मैं? ये लाइन इधर आया ना, v1 velocity. Is it v1 velocity? Will you all agree with me with this is v1 velocity?
Yes, sir.
Yes, sir.
Sir.
Does everybody agree with me? Sorry.
Yes.
Does everybody agree with me this v1 is the same as this?
Yes, sir.
Because length is the same, direction is the same. Now what about v2? v2 का length और v1 का length same होना चाहिए. होना चाहिए कि नहीं? क्या v1 और v2 का length same होना चाहिए? Yes, because their magnitude is the same. Okay. Can anybody agree with me if I make v2 like this? Sorry. Is it v2? This line with this line parallel. This line and this line parallel, and length is the same. Will you agree that this v2 is the same as this v2?
Yes, sir.
Yes, sir.
Okay. Now what about this? v2 minus?
Yeah. Delta V.
Is that right? This arrow is this minus this. Will everybody agree with me if I connect this to this and this v2 minus v1?
Yes, sir. Yes.
Okay. Now see, acceleration is equal to change in velocity by time interval. What is the direction of acceleration? Same as?
Velocity.
Same as?
Velocity.
No.
Speed.
Same as?
Change in velocity.
Yes. Yes. Same as change. You see, A is equal to delta V by delta T. So acceleration direction is the change in velocity direction, not velocity. So change in velocity is this. Now watch. This direction is towards the center O. Have you understood this now? This change in velocity has the same direction as what?
Towards center.
Towards the center. That is what I wanted to prove. That acceleration has the same direction as towards the center. That when a particle moves in a circle, this is the direction of acceleration. This is the direction of acceleration. This is the direction of acceleration. This is the direction. In fact, acceleration direction is along the radius vector. Acceleration का direction किस ओर होता है? रेडियस वेक्टर के अलॉन्ग होता है, अपोजिट रेडियस वेक्टर. अगर रेडियस वेक्टर ये है ना, लेकिन एक्सेलरेशन उल्टा है, सो एक्सेलरेशन इज नेगेटिव ऑफ रेडियस वेक्टर. ये रेडियस वेक्टर का उल्टा डायरेक्शन होता है. दैट्स ऑल. ये आज का लेक्चर बेसिक है और कल का भी शायद बेसिक रहेगा. इससे आपको क्या मिलेगा? यू कैन पास cbse एग्जाम, you can pass board exam, but then higher lectures will go to NEET, JEE, and advanced. Okay, let me stop the meeting now.
Sir, can you change the timing?
Okay, we can talk about that. No problem.
Sir, 15 minutes.
आपने आज ये स्टार्ट किया?
हाँ बेटा,
आपने आज ये कब स्टार्ट किया?
10 बजे स्टार्ट किया, 11 बजे बजने वाले हैं. We can talk about the timing. Don't bother. I will cooperate with you.
Sir, 15 minutes total late.